Now next conic section is ellipse. Ellipse it is obtained by intersection of a cone and a plane. How it is obtained, that already we have discussed. Now see, the special property for ellipse is that if you select any point on this ellipse, then with every point there exist two fixed points. Let me call them F1 and F2. These are fixed points. P is a variable point. So in the plane of this ellipse, in the same plane there exist two fixed points such that distance of this variable point from F1 and F2, we say distance F1P, F2P. Distance F1P plus F2P. Suppose this is 3, this is 7, so total is 10. Now when P moves at this point, suppose we say Q. Now distance of Q from F1 and from F2, as this point P has changed its location, these distances are changed. Let me denote this point as P dash, or we can say P1, P2. This point is P1, now this point is P2. So distance of P2 from F2 and F1 will be changed. Say here this is increased, so this is decreased. If this distance F2P is 8, then this will be 2. So 8 plus 2, it will be 10. So F1P2 plus F2P2, it is 10. When P comes at this point, anywhere on this ellipse, suppose P is coming at this point, suppose it is P3, then distance of this point from F1 and from F2, so sum of these two distances, that is F1P3, F2P3, so sum of distances, it remains constant. If this is 5, this is 5, this will be 5. If this is 4, this will be 6. Total remains constant, 6 plus 4, 10. So if we select any point on this ellipse, then distance of that point from two fixed points and their sum of distances of any point, it will be always constant. So that is the property of set of points of ellipse. So here now I am putting words in definition, that an ellipse is the set of points in a plane An ellipse is the set of points in a plane such that this sum of distances of every point from two fixed points in the plane is constant, and that diagram again I am putting here showing this property. This is ellipse. This point is F1. This is F2. P is variable point. F1P, F2P. For any point P. So P is variable point. It's a distance from these two fixed points F1 and F2. That is F1P plus F2P. So sum of distance, it is always constant. So that is property of an ellipse. Now, terminology means words, mathematical words in case of ellipse. Here, these fixed points are said to be foci. Here, F1 and F2. These are fixed points. Are said to be foci. That is a plural form of focus. There are two focus. F1 is focus, F2 is focus. So these are focus. So this is plural form of focus, that is foci. Now, here in this ellipse, see again I am taking this diagram. This is F1, this is F2. Joining these 2 points, we are getting a line segment. And midpoint of this line segment is said to be center of this ellipse. Let me denote the center by O. Midpoint of line segment joining F1 and F2. Midpoint of line segment F1 F2 is said to be the center of ellipse. Now, if we take a line passing from F1 F2, this is a line passing from F1 F2, that means passing from this foci. This is a chord of ellipse. So this chord passes from this foci. So a chord passing from foci this is said to be the major axis. It is said to be the major axis of ellipse. If I denote here point A and here I keep A dash, then line segment A dash A, this is major axis. Here A dash or A dash A, this line segment is major axis. Then I take perpendicular from this center, taking a chord which is perpendicular to center, perpendicular to major axis, passing from center. Let me say this as BB dash. This is said to be the minor axis. So a chord passing through center and perpendicular to the major axis is said to be the minor axis of this ellipse. Now, distance between foci, some notations. There are some notations. Distance between two foci, distance between foci, that is distance f1 f2, it is denoted as 2 times c. This distance is 2 times c. So that means distance of any focus from center, it is c. Or rewriting this statement by this way, that a distance of any focus from center is equal to c. So therefore distance between two foci is denoted by 2 times c. This is c, this is c. So this distance is 2 times c. Distance between two foci is 2 times c. Then length of major axis, length of a major axis, that is line segment a dash, it is denoted as 2 times a. Length of a major axis is 2 times a. Length of minor axis it is denoted as 2 times b. This length is 2 times b. So here we are denoting distance between this a and a dash. This distance is 2 times a. So that means this distance is a. So this is length of semi major axis. So length of semi major axis is a. Now distance between b and b dash, this distance is denoted as 2 times b. b dash is 2 times b. So therefore this distance will be b, that is length of semi minor axis. So length of semi minor axis is b. Here ends of major axis are said to be vertices. Ends of major axis are said to be the vertices of this ellipse. Here A and A dash are vertices. So here it is clear that distance of any vertex from center is A. distance of any vertex from center, it is A. So in this discussion we discussed major axis, minor axis, vertices, foci, center. So these are the words related with this conic section ellipse. Now eccentricity. Eccentricity of ellipse. Now what means eccentricity? See, its notation is E. E is eccentricity of ellipse. Its definition is, it is ratio of C and A. Ratio of C and A, that means what? So in words we can say that eccentricity is equal to ratio of, what is C? C is distance of any focus from center. Distance of any focus from center. And A. So what is A? A is length of semi-major axis. Length of semi-major axis, or we can also say length of semi-major axis, that means distance of any vertex from center. So these words can also be written as, it is nothing but distance of any vertex from center. So eccentricity is ratio of distance of any focus from center and distance of any vertex from center. So that is eccentricity. Now standard equations. There are two types of standard equations. First equation is, if ellipse is such that if a major axis is along x-axis, see, major axis is along x-axis, minor axis is along y-axis. This is center. Center is at origin. This is A. This is A dash. This is B. This is B dash. If a major axis is along x-axis, major axis is along x-axis and center is at origin, and center is at origin, then this will be the diagram of such ellipse. Now we denote distance of any focus from center is a C. If here F1 is focus, F2 is second focus, distance of focus from center is C. This distance is C. So coordinates of focus, this point is C0, this F2 will be, here I am putting F2, this will be minus C0. So coordinates of foci are C0 and minus C0. Then So distance between two foci is 2 times c. So this is now 2 times c. It is clear. Distance of any vertex from center is a. This distance is a. A is vertex. So if this distance is a, coordinates of a are a0, and hence coordinates of a dash are minus a0. Then length of semi minor axis is b. Length of semi minor axis is b. Length of minor axis is 2b. This is 2b. This distance is 2b. So we can say this is b. Length of semi minor axis is b. So coordinates of b are 0b. This is 0 minus b. So equation of this ellipse is, if major axis is along x-axis, center is at origin, then equation of this ellipse is x square upon a square plus y square upon b square equal to 1. See here, this length is greater, this length is smaller. Because major axis is along x-axis, denominator of x square, this will be greater, where a square is greater than b square. Major axis is along x-axis, so denominator of x square is greater than that of y square. Now here, see, vertices are, here vertices are a0 and minus a0. These are coordinates of vertices. Foci are coordinates of foci plus minus c0. These are foci. These are ends of minor axis. Length of major axis is 2a, length of minor axis is 2b. Say E is c by a. So c can also be expressed as a times e. C is a times e. So this can also be expressed as AE comma 0. If E is given, this formula can be used. Then second equation, if major axis is along y-axis, second standard equation is, if a major axis is along a y-axis, major axis is along y-axis and center is at origin, if a major axis is along y-axis and center is at origin, then this curve will be like this. Major axis is along y-axis. Ends of major axis, A dash, these are ends of major axis, these are vertices. This is center. This is minor axis, B dash. We always take distance of vertex from center is A. This distance is A. So coordinates of A are 0, A. Coordinates of A dash 0 minus A. Coordinates of B, length of a minor axis, we are always taking it 2 times B. This is 2 times B. So this will be B. So take this as B0, this as minus B0. Foci. Here foci lie on y-axis. This is F1, this is F2. Coordinates of foci 0, C, 0, minus C. This is 0, C, this is 0, minus C. Because we have already taken distance between foci is 2 times C. Distance of any focus from center is always we are taking C. So this will be 0 C, this will be 0 minus C. So here, if major axis is along y-axis, then equation of such ellipse is x square upon y square upon, see what is the difference? Major axis is along y-axis and length of major axis is 2 times A. Distance of vertex from center is A. So below y square, put here A square. And below x square, put B square. Because major axis is along y-axis, denominator of y square is always greater. So here A square is greater than B square. In both cases, length of major axis is 2A, length of minor axis is 2B. Distance between foci is 2 times C. These symbols, these values we are maintaining in this both cases. Here vertices are 0 plus minus A, or vertices are A, 0A and A dash 0 minus A. These are vertices. Foci are 0 plus minus C, or this can be also taken as foci is 0 plus minus C is A times E. If E is given, then it can be found by this formula 0 plus minus A. Then length of lattice rectum. Length of lattice rectum, that is length of lattice rectum, that is if we take ellipse, these are foci F1 and F2. This is major axis. Here it is center. If we take a chord which is perpendicular to major axis passing from focus, then these chords which are perpendicular to major axis passing from focus, so these are said to be lattice rectum. So these are lattice rectum, this line segment and this line segment. These both are lattice rectum. If major axis is along y-axis and here this is F1, this is F2, This is major axis. Then ellipse is such that major axis is along y-axis. This is minor axis. Here F1, here F2. Then a chord which is perpendicular to major axis passing from focus. Then these line segments are lattice rectum. So a chord passing through any focus and perpendicular to major axis is said to be the lattice rectum. And length of lattice rectum formula for length of lattice rectum is 2 times b square upon a. In both the cases, length of lattice rectum is 2 times b square upon a. In both the cases, length of major axis is 2a. In both the cases, length of minor axis is 2b. Distance between foci is 2c. Then coordinates depends upon whether major axis lie along x-axis or it lies along y-axis. Accordingly, we take here coordinates. So in both equations, these equations are said to be standard equations. This is first standard equation, this is second standard equation. And look, what is the difference? If major axis is along x-axis, denominator of x square is greater, to which we call a square. And here, if major axis is along y-axis, this will be greater. So in any equation, observe denominator of x square and y square. If here 1 is given, first of all RHS must be 1. If equation is in this form, then observe these denominators. If you find denominator of x square is greater, take that number as a square. Discuss according to this diagram. If you find denominator of y square greater, take that number as a square and discuss according to this diagram. Then relation between A, B and C. That means length of a semi-major axis, length of a semi-minor axis and distance of any focus from center. So relation between these three numbers is c square is equal to a square minus b square. So from a square and b square we can calculate value of c. So c will be equal to root a square minus b square. See here c is distance. C is distance, so we consider here positive square root, positive value of c. C is distance of focus, any one focus from origin, from center. So this is the formula to calculate C from A and B. Now let us find these values. Question is, find coordinates of vertices coordinates of foci, length of major axis, length of minor axis, eccentricity, and length of lattice rectum. Now we are taking question to find these all values, coordinates of vertices, foci, length of major axis, length of minor axis, eccentricity, length of lattice rectum, etc. Suppose equation is x square upon 25 plus y square upon 16 is 1. First of all, check equation, it must be in standard form. Here there must be 1. This is 1. In numerator, coefficient of x square is 1, coefficient of y square is 1. Then check denominator. See here, this number is greater. So a square is, whatever is greater value, take it as a square. This is b square. So a is, that is, this is length of semi major axis, length of semi minor axis is 4. So we have obtained length of semi major axis 5, length of semi minor axis 4. Therefore length of a major axis is 2 times a. Length of major axis is 2 times a, so that is 10. And the length of minor axis two times b, that is 8. So from given equation, first of all get a square and b square, then a and b, then their double values are length of major axis and minor axis. Now we can calculate c by this formula. C is equal to square root of a square minus b square. So square root of a square is 25, b square is 16. So c is root 9, that is 3. So this is distance of any focus from origin. Therefore foci are, here coordinates of foci are clear now. So coordinates of foci so here major axis is along x-axis. See, from equation you can imagine it's a sketch. To avoid mistake in calculation, you can imagine it's a diagram, because denominator of x square is greater. So major axis is along x-axis, minor axis is along y-axis. This will be the sketch. Here a dash, these are vertices. So here from this diagram, from this equation, denominator x square is 25, so put here 50, here minus 50. That means plus minus a0, vertices, coordinates of vertices, plus minus 50, plus minus a0. Formula was plus minus a0, that is plus minus 50. This will be b, 0b, 0 minus b. So from this number 0, 4, 0 minus 4. Here foci f1, c0, this is 3, 0, f2 will be minus 3, 0. So coordinates of foci plus minus c0 plus minus c0, so plus minus 3, 0. Major axis is along x-axis, so foci lie on x-axis. So their x coordinate with their y coordinate we are taking 0. Vertices lie along x-axis, so their y coordinate we are taking 0. So coordinates of vertices, coordinates of foci, length of major axis, length of minor axis. Now eccentricity. Eccentricity E is, formula is C by A. C is 3 and A is 5. So eccentricity is 0.6. See, eccentricity of ellipse is always less than 1. Eccentricity is a ratio of lengths. So this is always positive value. But in case of ellipse, eccentricity of ellipse is always less than 1. Positive value less than 1. Length of lattice rectum. Length of lattice rectum. Formula is 2b square by a. 2b square by a. Now b square. What is b square? B square is 16. A is 5. So 32 by 5. So this is the method to find these values. Now let me take second example. Suppose we want x square upon 7 plus y square upon 25 equal to 1. We want to find everything for this equation. Now look here. Denominator of y square is greater. This is greater. So its major axis lie along y axis. So its major axis lie along y axis. So this is the second type. This is center. This point, now we are taking A dash, ends of major axis, which are said to be vertices. So vertices are 0a, 0 minus a. What is here now? A square. Here a square is 25. Greater value you take a square, smaller value you take b square. Major axis is along a y axis. So 0a, 0 minus a. So this will be 0, 5, 0 minus 5. Because a is 5, b is root 7. This will be root 7, 0. This point will be minus root 7, 0. So here length of major axis, always we are taking length of major axis 2 times a, 2 times a, that is 10. Length of a minor axis 2 times b, so 2 times root 7. Then we calculate c. C is square root of a square minus b square. So c is square root of a square is 25, b square is 7. This is root 18. So this is 3 root 2. So C is 3 root 2. C is 3 root 2. So foci are here, coordinates of foci. Coordinates of foci. Foci lie on y-axis. This will be F1 0 C. This will be F2 0 minus C. What is C? 3 root 2. So 0 3 root 2. 0 minus 3 root 2. So 0 plus minus C. Here it was plus minus C0. Here 0 plus minus C, because major axis lie along the y-axis. So foci lie on y-axis. So it is 0 plus minus 3 root 2. These are vertices. Coordinates of vertices. Plus minus E, 0 plus minus A, because major axis lie along y-axis, ends of major axis are on y-axis, so their x coordinate 0. Here it was plus minus A0, here it is 0 plus minus A, so that is 0 plus minus 5. Eccentricity. Eccentricity, E is C by A. C is 3 root 2. A is 5. So this is eccentricity. C upon A. A is 5. Length of lattice rectum. Two b square by A. Formula is 2b square by A. That is 2 into b square is 7 and A is 5. So 14 by 5. So that is length of a lattice rectum. Now 36x square plus 4y square is 144. This is not in standard form. To convert into standard form, first of all check right hand side. This number is not 1. So to get here 1, we divide this equation by 144. So dividing by 144, 36x square by 144, 4y square by 144 equal to 1. Then this is x square upon, now 36 into 4 is 144 plus y square upon, now 144 by 4, that is 36. This is 36 equal to 1. So 36 into 4 is 144, 36 into 4 is 144. Now look here, which is greater? This number is greater. So this number we are taking a square. A square is 36 and this number we are taking as b square. B square is 4. So here A is 6 and B is 2. And major axis lie along y-axis. We are taking major axis along y-axis. So this will be ends of major axis. So vertices, this is center B, B dash. Here we will keep foci F1, F2. This is center. So length of a major axis, length of major axis is 2 times A. So it will be 12. Length of a minor axis, it will be 2 times V. So it will be 4. 2 into 2 is 4. So this will be 0a. This will be 0 minus a. So vertices are coordinates of vertices 0 plus minus a, that is 0 plus minus 6. So these are vertices. Now to find foci we need value of c. So to find c, c is square root of a square minus b square. So square root of a square is 36, b square is 4, it is root 32, so that is 4 root 2. This is c. So foci are 0c, 0 minus c. So foci are 0 plus minus c. These are foci. Now eccentricity. Eccentricity E is c by a. C is 4 root 2 upon E is 6. So this is 2 root 2 upon 3. This is eccentricity. See, always remember one point, that eccentricity E of any ellipse is the number such that its value is always between 0 and 1. Eccentricity of any ellipse is always number between 0 and 1. It cannot be more than 1. Length of lattice rectum. Length of a lattice rectum is 2b square by a. B square is 4, a is 6. So that is 4 by 3. So this is length of lattice rectum. Find equation of ellipse satisfying given conditions. See here, vertices are given 0 plus minus 3. Foci lie on y-axis. Here foci lie on y-axis and vertices also lie on y-axis. So required equation is, it will be of this form. Foci lie on y-axis, major axis lie along y-axis, so denominator of y square will be greater and denominator of x square will be smaller. So this will be the equation of ellipse. If foci lie on y-axis, put a square below y square. Denominator of y square will be greater. Now here vertices, that is 0 plus minus a. 0 plus minus a is 0 plus minus 13. And foci 0 plus minus c is 0 plus minus 5. Vertices, ends of major axis and foci given. So comparing these values, a is 13 and c is 5. So a square is 169, c square is 25. Now to find b square, we use relation between ca and b. C square is a square minus b square. C square is 25, a square is 169 minus b square. So b square is equal to 169 minus 25, 144. So this is b square, this is a square. Putting values in this equation, therefore required equation of ellipse is x square upon b square plus y square upon a square equal to 1. This is required equation. Now see here, vertices are on x-axis, foci on x-axis. So because these lie on x-axis, denominator of x square will be greater. So below x square put a square, below y square put b square. Foci lie on x-axis, so major axis lie along x-axis. So keep a square below x square. This number will be greater. Now here vertices, that is plus minus a0, it is equal to plus minus 60. And foci plus minus c0 is plus minus 40. So by comparison, a is 6 and c is 4. So a square is 36 and c square is 16. So now c square is a square minus b square. So 16 is 36 minus b square. So b square is equal to 20. So say here a square is greater, b square is smaller. Putting these values in this equation, so required equation is x square upon a square is 36 plus y square upon b square equal to 1. This is required equation of ellipse. Now here ends of major axis. See, major axis lie along y axis. It is clear. Ends of major axis, that is these are 0 plus minus a. Major axis lie along y axis. So required equation is x square upon b square plus y square upon a square is 1. Ends of major axis lie on y axis. So denominator of y square keep greater. Now here 0 plus minus a is 0 plus minus root 5, and these are ends of minor axis. Ends of minor axis, plus minus b0 is plus minus 1 0. So here a is root 5 and b is 1. So a square is 5, b square is 1. And putting this value in this equation, therefore required equation is x square upon a square plus y square upon b square is 1. This is required equation of ellipse. Now we want equation of ellipse whose major axis lie on the x-axis and ellipse is passing from these 2 points 4, 3 and 6, 2. Because major axis lies on x-axis, its equation is x square upon a square. See, below x square I am putting a square because major axis lies along x-axis. So x square by a square plus y square by b square equal to 1. Now given that it passes through these 2 points 4, 3 and 6, 2. This ellipse, its major axis lie along x-axis, and given that it is passing from 4 3, suppose somewhere here 4 3 and 6 2. So points lie on this ellipse. So each one will satisfy equation of ellipse. Therefore 4 3, putting in this equation, putting here 4, so 4 square is 16 by a square, plus put y equal to 3 square is 9 by b square equal to 1. This is equation 1. And putting 6 2, x equal to 6, so 36 by a square, plus put y equal to 2, so 2 square is 4 by b square equal to 1. This is equation 2. 6 2 and here 4 3 is taken. Now we solve these equations. So observing these equations, say here this number is 9, this number is 4. So we multiply equation 1 by 4 and equation 2 by 9, and taking subtraction we can eliminate the second term. So we are solving these equations 1 and equation 2. This equation I am multiplying by 4, so 64 by a square plus 36 by b square equal to 4. This equation I am multiplying by 9. 36 into 9 is 324. 30 into 9 270. Sorry, 9 into 6 54, then 5 27 plus 5 32, 270 plus 54, it's okay, 324. So 324 by a square plus 4 into 9 36 by b square equal to 1 into 9 is 9. So second equation is multiplied by 9. Now taking subtraction, minus minus minus, this will be cancelled. 64 minus 324, 64 minus 324, that is first of all remove 24, then still 40 is left, then removing 40, so what is left, 240 will be left. So 64 subtracting from 324, remove 24, then 40 is left, so 260 is left. So minus 260 upon a square equal to 4 minus 9 is minus 5. So that is a square equal to 260 upon 5. So 5 into 5, 25, 2. So a square is 52. A square 52. Now we are putting in equation either 1 or 2. So putting in 1, 16 by 52 plus 9 by b square equal to 1. So 9 by b square equal to 1 minus 16 by 52. That is 9 by b square is 1 minus, this is 4 by 13. So this is 9 by b square equal to 13 minus 4, 9 by 13. So b square is 13, therefore b square is 13. So b square is obtained, a square is obtained. So required equation, therefore required equation is x square upon a square plus y square upon b square equal to 1. See, you can also express this equation by this way. If I multiply this by 52, then x square plus 4y square, it is equal to 52. This can also be expressed by this form. An arc in the form of a semi-ellipse, it is 8 meter wide and 2 meter high at the center. Say, arc in the form of semi-ellipse. So suppose this is an arc in the form of semi-ellipse. At the center, it is 8 meter wide. So here width is 8 meter. This is 8 meter. This is center. Height is 2 meter. So here this height, it is 2 meter. This height is 2 meter. So here, because it is semi-ellipse, this is length of a major axis. Length of major axis is 8 meter. So length of semi-major axis is 4 meter. And if we take this line as x-axis, this line as y-axis, then coordinates of this point will be 4, 0. Coordinates of this point will be 0, 2. This will be minus 4, 0. This is major length of a major axis, 8 meter. So here 2 times A is 8 meter, and this is semi minor axis. This length is B. B is 2 meter. So A is 4 and B is 2. So equation of ellipse is x square upon a square plus y square upon b square is 1. Therefore, x square upon 16 plus y square upon 4 is 1. This is equation of this ellipse. Now question is, find height of the arc at a point 1.5 meter from one end. Suppose from this end, at 1.5 meter distance, suppose this is the point, let me say point is P, whose distance from this A is 1.5 meter. This distance is 1.5 meter. So suppose that PA is 1.5 meter. PA is 1.5 meter. OA is 4 meter. So therefore OP, this distance will be 4 minus 1.5. 4 minus 1.5. So OP, it will be 2.5. So this distance will be 2.5. It will be 2.5. This point is point P. It is point P. So coordinates, x coordinate of this point P. So here this is required height. So required height, let me say this point is point Q. PQ is required point. So this height we require, let me say h. So coordinates of Q will be, its x coordinate will be 2.5 and y coordinate will be h. So therefore required height, if required height is h, this required height is h, then coordinates of Q will be, its x coordinate is 2.5, y coordinate is h. Now Q lies on this ellipse. So as Q lies on ellipse, coordinates of this point will satisfy this equation. So therefore these coordinates we are putting in 1. So putting value in 1, therefore x is here 2.5, so 2.5 square upon 16, x square upon 16, plus y is h square upon 4 is 1. Therefore h square upon 4 is 1 minus, this number will be 6.25 upon 16. So therefore h square upon 4 is 16 minus 6.25 upon 16. So h square upon 4 is 16 minus 6.25, that is 9.75 upon 16. So therefore h square is 9.75 upon 4. So h square is equal to 4 into 2 8, 4 into 4 16, again 4 into 3 4 into 4 16, 1 is left, its approximate value is 2.44. So therefore h is square root of 2.44 meter. So we can calculate using calc its approximate value. So this is the height of arc at a point which is 1.5 meter from one end.